Good evening. Hopefully everyone is doing well. Hopefully everything's coming up right. All right, so I think I need to work on my intro part of it because it's hard to get that straightened out to know exactly what's going on. But we'll figure it out. Okay, so a couple things. Posted exam 2, so that's live today. I think I should be able to back off on the lecture on Thursday this week, because that way you guys have a chance to spend a little bit more time on the exam. So let's plan to do that this week. Which puts us further and further behind schedule. But again, we had a lot of open space at the end. So that's what the plan is. Today we'll finish chapter 8, and then we still have 9, 10, and 11 left. But even if it takes a week to do each one, we will still have a couple of weeks at the end. So it's not an issue, really, honestly. No, and we'll see. Maybe depending on schedule, we might do exam 3. We might move that up a little bit. We'll see. I'll keep you guys informed as we move forward. Now I'm just looking at the schedule here. Next week would be assignment for chapter 7, and then one for chapter 8, and then so. Yeah, so it looks like we're going to end up with, if we want to do one assignment per chapter, and I'd like to do that, we're going to end up with having an assignment due over Thanksgiving. I'll probably make it due the Monday after Thanksgiving, just to give you guys that little bit of extra time. Because I know Thanksgiving can be a nice break for you guys, the winter break. So we'll do that. More information on that after the exam. So also I finished grading assignment 5 and assignment 6, so that you guys would have that to work on, or not that to work on, but that to look at. So let me quick. I'm gonna bring this off to the side so I can do it in my space here. Let's open up assignment 5. I just want to see if there was any. Oh, I don't want the Word version. I want the PDF. There we go. So let me just look here. 3 types of buses. No problems there. I don't think anyone had too much trouble with this one. So the big problem here. What's the difference between byte addressable and word addressable? When I say addressable, we're talking about how to actually get to the memory. So you needed to talk about that somehow. Explain why there's a difference, but 12 bits and 16 bits. That's pretty straightforward, because the Mars is just an address, and it's actually, oh, did I put that wrong? I think I put that wrong. It's actually MAR, isn't it? MAR, not Mars. Oh, yeah. Yep. The MAR register. That shouldn't be an S. Explain the names and functions of all the registers. That includes MAR and AC and 5 others. There were 7 total. And I believe there's a question similar to that, so pay attention to that when it comes to the exam. All right, so here, there's a couple interesting things that I should point out. I think most people caught it. A couple of you didn't. There's an I right here, and this I changes it to indirect. And so that was something we didn't talk about too much. I talked about the difference between direct and indirect addressing. The interesting part is here, when we add A and B together, FC plus this isn't 14, it's actually just E. So when we add those two together, we get 10A. Well, 10A is actually an address. And that's this address C. And so it's a little tricky. So just pay attention to that when you're doing that. So it wasn't a huge deal, but it changed things. Some people interpret this as being a mistake by myself. And if you did interpret that as a mistake, that I shouldn't have put the I there, then I graded it as if it wasn't. So there was 2 different versions. I think almost everyone got it, but I think there might have been 1 or 2 people who didn't. And so then the hex codes, right? Each one of these is turned into a hex code. So like load is, I think, 1. And so then we would put 1 plus the address of A. So then it'd be 1101. And then we'd continue on down through the line. Add, I think, is 3. So 3 of B, so 3 would be 3109 because we're putting the address of B there. And then store, I don't remember what store is. Whatever store is, then you would put that in there, and then you just continue on down the line through your opcodes. So the difference is the opcode for add I wasn't something I had covered before, and so you would have had to look that up yourself. But it is out there. Maria has those out there. All right, so, and almost everyone went and figured it out. Okay. And then this one, it says, what's the value stored in AC after each instruction? So that would be 8 instructions, because the last ones here are not instructions. Although, yeah, it doesn't even make sense. You can't do that. So, all right, that's what that is. If there's any questions about that, let me know, including if we have late comers, or you're welcome to put comments in later. So then let me open up number 6. So the big thing here is some people told me the difference, why it would become a problem, and that's good, but I also was looking for here why. Why is it a problem? And so, right, part of the problem is Big Endian and Little Endian use different styles of putting the bytes in order. And so, because of that, it becomes an issue. And we do have to translate between the two. And we can. In fact, actually, I think I talked about that a little bit when I talked about the Indianness of things. Most network nodes, like routers and things like that, run on Linux or Unix. And in that case, they use the opposite of what Microsoft does. I think Microsoft uses Little Endian, but they use Big Endian. So it has to make that translation between them if it's going to do any kind of looking at the data. Which most of the time it doesn't, but it could. Okay. And then I think most people hit on the stack thing. Just looking for more detail on that. Every single person caught that I forgot to put a parentheses at the end of this. You guys did a great job there. I think everyone got full credit on this one. Maybe not. If it wasn't everyone, it was very, very close to that. Same with this one. I liked your guys' answer. You guys did a good job on that. Direct versus indirect addressing. You just had to talk about what's the essential difference, right? Some people just put some real basic stuff, and then give an example. It was a good thing. And then pipelining in a CPU. I think there was one person who did pipelining on a network, which is a little different. Yeah, a little different. But in this case, right, it's like a layer. It's like layering. I'm trying to think of a better way to think about it. In some ways, it's like an assembly line. So, in a normal situation, you've got an assembly line where each station, right, has a different thing. And say we're building a car, right? So we're going to go along and we'll put on the driver's door, and then we're going to put on the passenger door. It's a sports car, so it only has 2 doors, right? So we're going to put on the driver's door, we're going to put on the passenger door, and then we're going to move it along, and then we're going to put on the hood, and we'll move it a little farther, and put on the trunk, and move it a little farther, put on the front bumper, right, as we go. Now, in a regular system, a car goes into the system and it has to go all the way through all these points before and when it gets to the end, then it's a finished product, and then we go back to the beginning and get a new shell for our car so we can install our doors and hoods and stuff. Now, in pipelining, it's different. So what we'll do is we'll have one car that will enter, and then we'll put on the driver's door, and then we'll move it along to the next station. And then, so then the person or process in this case, that's putting on the driver's door is just going to continue putting on driver's door. And so maybe they're doing fetching. So they're just fetching that thing. Fetch, fetch, fetch. And they go and fetch it over and over again. And then all they're doing is fetching and putting the new opcode into the IR, the instruction registry. And then when they're done doing that, then they move it along to the next station, which is then going to put on, say, the passenger door, or move it along, and then the next one will do the next step. So what you're doing is, in a lot of ways, you're doing things in parallel. So instead of having one process that's going on at a time, we're going to have 5. Usually it's broken down into 5 steps. That's the idea of pipelining. Okay. The exam, if you'll notice on the due time for the exam, it's actually end of day, so 11:59 p.m. So I extended that time for you guys, just to have that little extra time to work on it. Although my hope is that you're not working on it on a Friday night, because Friday night is for doing other things, like, I don't know, trying to relax and deal with the long week. But that's all up to you on your time management. It's not my business. Okay, so is there anything more? I'm going to try to get 7 done tomorrow. If it's not done tomorrow, I'm going to continue working on it on Wednesday. So I want to get those done as quickly as I can so you guys have that feedback. Okay. Anything else? Well, there's one thing that I do want to talk about at least a little bit, is that I'm a big proponent of doing object-oriented programming, although the turn's just coming off that a little bit, in that I'm realizing there are some drawbacks to it, but that's a different story. The rationale is that code is, and now that I've been in industry for almost 3 years, I'm absolutely convinced that this is important. In the life cycle of a program, we have a lot of different things, and you might learn about this if you take something like software engineering at some point. Most of the time, most of you will be required to take that. But in software engineering, you learn about the different life cycle of a program. Well, one of the things that's the most important, it's not the most important. Let me back up. It's not the most important at all. The most important is creating a product, right, that runs good so that you can sell it. But then after you've done that, then you need to be able to maintain that program. What I mean by maintain is you need to be able to make changes to it. Because no matter how hard you try, there will always be bugs. No matter what. It just happens. It's just the way it is. So every time you make a change to the program, it's likely that you created 1 or 2 new bugs, which is infuriating when you're trying to fix a bug. When the change that you make is to fix a bug, then you likely created 1 or 2 more bugs. So that can be infuriating, but sometimes those other bugs are really small, and it doesn't always happen. But maintenance of code is one of the most important things, because it lasts for a very long time. So it might take you 6 months to a year to create a product, but then you will be maintaining it for the rest of the life of that product. And so most of what I do is maintenance of code. So maintainability is very, very important, which means you need to be able to go back and read it. So I don't want to go too far down this line, but I do want to recommend a book to you guys. And I have a copy of it. And the book is called Clean Code by Robert Martin. And let me show it to you. I've got a copy right here. It has a cool universe on it. And let me try to bring that up so you guys can really see it there. Clean Code, and then Robert C. Martin. And that is otherwise affectionately sometimes called Uncle Bob. Robert Martin. So, Clean Code, here's an interesting rule in Clean Code is he's actually quite funny when you read the book, so it's amusing to read as well, so that's always fun. So here's the first rule of creating a function or a method in using the Clean Code rules is write it short. It needs to be small, as short as possible. And then the second rule is no, shorter than that. So it's just not long. It's just not short enough. You didn't make it short enough. So he says that the ideal length of a method using Clean Code principles is one line, and it should never pass anything in and never pass anything out. So although those are almost impossible to do sometimes, depending on the way your system is set up. All right, so just giving you a little bit of that's just some advice about general programming, and we're going to talk about some more things too. Okay, so we're talking about operating systems, right? We're still talking about operating systems. Okay, in operating systems, so what did we talk about so far? I don't even remember. Oh, that's right. We talked about we didn't. It's not operating systems. It's system software we're talking about. And the main thing that we talked about is operating systems. And a little bit about how they work and what they work on and what they kind of manage. Okay, so the other thing we can do that's also potentially a system software, that is system software, and that is, it's a category of things called protected environments. And so what we can do is we can actually set up a process that can't be messed with by other processes. That's maybe the easiest way to say it. So it's kind of independent of everything else. To a certain extent, all programs are like that, but we're actually talking here about being able to reserve things and make it look and feel like it's different. You'll understand in a second. So the thing I want to talk about, the first thing I really want to talk about here. So let's actually make a box here. Go here, make it 36, like I have been doing. Okay, yeah. Virtual machines. So what is a virtual machine? So I use one every day, so I've become much more familiar with them. So a virtual machine is a program that simulates a complete computer system. Let me bring that out a little bit here. So what that means is, so let's say we have this huge server, right, that has has 128 megabytes of RAM. It has specific processors, whatever, it doesn't matter. It has all these different kinds of systems. Or it could be a server farm that has lots of different chunks of systems all over the place. So what we can do is we can carve out, we can say, okay, this computer gets four cores, and we're going to reserve these 4 cores for it, and then we're going to reserve, say, 16 megabytes of RAM, or whatever it is, or gigabytes, sorry, it wouldn't be megabytes, what am I thinking? gigabytes of RAM. So it's going to reserve a certain amount of resources specifically for this system. Reserved for this. I'm going to put quotes around system, because it's not really a system, it's just a computer program that's simulating a system. So this is very, very useful. In fact, for my work, it's great because I can log in with my laptop into a computer that's actually on the server for the place that I work, which means I'm inside or behind the firewall, which also means then that the IP address for it's actually called a VDI, Virtual Development Environment, which is a subtype of a virtual machine. So those resources, the resources that it has are reserved for me. And that's not completely 100% correct. It's not reserved. It's just the maximum that it can use. And so if I'm not using all of my resources, it can actually be allocated to somebody else. It's a really great way to run a lot of different computers at the same time without actually having to have all of the hardware for them. Now, it turns out that my laptop is actually better than the VDI that I use, but that's just a detail. It wouldn't have to be. It could actually be a machine that's not that good, but it happens to be that my consulting company gives me a pretty decent laptop for programming, and then I get a VDI that's not as good. So, just the way it is. And my client gets to decide that, not me. Or our company, for that matter. So here's the interesting part. I've already demoed to you or shown you a virtual machine in reality. In that, when we went down here, remember I clicked on this and I showed you something called a command prompt. Oh, actually, where? CMD. So CMD is a command prompt. This, I'll just open it up over here. Oh, now you know my username. I don't think it was that much of a surprise to get that. So, we also know my Windows version. Oh man, you guys are ready to hack me. Good luck. Our network administrator is top notch. I'm sure he's got plenty of things in place. Okay, so plus it would be kind of illegal, so whatever. But so this is actually, it's not going directly to the operating system. This is actually a virtual machine. It's virtually acting as if it is MS-DOS. It's not actually DOS. That actually ended, I think, with Windows 95. If it wasn't 95, it was XP. It's possible that XP is when that happened. But that was a long time ago in either case, right? That would have been early 2000s. So it's been almost 20 years. And this has been, so pretty much as long as you guys have been alive. DOS hasn't really existed. Not in a real sense, in a virtual sense. All right, okay. So if they're protected, right, they can't be used by other people. But it really is a maximum amount of resources. This is only partially true, I suppose. Like, if you have access to a printer, it's probably a physical printer somewheres, and that printer would be usable by a bunch of different systems, potentially. So, there's different ways to set things up. But the cool thing about them is that, oh, actually, I haven't talked about why they're super. Well, first off, they're very, very nice because like a company like my client Thomson Reuters can create thousands of them, and when they create thousands of them, let's say I'm not using a lot of resources on my computer at the current time, right? I'm just typing away at a couple things, but I'm not actually running anything. I'm just working on a problem. Maybe I'm doing some web searching or things like that. So, in fact, actually, it's amazing how little code you actually create in a day. Like today, I don't think, no, I did not write a single line of code today. So, and it's not unusual, especially as a QA person to do that. So, but there are days when I might write 50 or 60 lines of code. I did do a code review today, though, so I was in the code. Anyways, and I was running tests, so there's plenty of that to do, too. Anyways, if I'm not using a resource, and if I'm not compiling anything, I'm not recompiling our source code, there's a good chance that I'm not maximizing my system. So because of that, if I'm not maximizing my system, somebody else can use those resources. Now they're reserved for me, which means I can use them up to a certain maximum, except somebody else can use them. So it helps. I think the correct word is amortize. Let me explain what that means. That means spreading out the load. So you could, like, if you amortize the load, yeah. So it means spreading it out across all the systems in this case. So what it would do is, say one of my coworkers or somebody even that works for the company but I don't even know happens to be running a compile at that time and they're maxing out their system, which is fine. It doesn't hurt me. I can lend them part of my system so we can overload, so we can use more than the server should allow, unless everyone is pushing the maximum, in which case everything gets bogged down. And we have had that happen. So that's one of the advantages. One of the other advantages is VMs are extremely easy to spin up. I mean, in a matter of seconds, you can spin up a virtual machine. Can do a task with it and then have it pulled down before you would even go in to be able to set up the desktop to be able to run that separate program. So they're very, very useful when it comes to those kinds of things. Another thing, what's the other? Geez, now I'm completely dropping the ball on this. Why VMs are really useful? Well, yeah, easy to create them, and there's potential for resource sharing to help share the load. Yeah. All right. So there are other subsystems there are other things that we can create that are also systems, and that would be. We can create subsystems in a computer. And when I'm talking about a computer, a lot of times when I'm talking about subsystems, really we're talking about servers, although it might be a single PC, but it's probably a server. So we could do things like, they call it a print spooler, which would be, print spooler might be not the right word, like a way to a print controller, so that if there's 100 people in the office and they're all tied into the same printer bank, it could figure out, like say there's 3 or 4 printers in the printer room, then it can decide which printer to print off your thing on, and then it all sits in a queue, and first come, first serve, or however it decides to do it. it can unify all of those print jobs that are going to the print room into one kind of system. That would be a subsystem that a server might actually take care of. Another thing would be RAID. Actually, we just talked about that last time. So, right, redundant array of inexpensive disks, or now we would call independent disks. And so, instead of inexpensive, so that we could set up RAID on there. And that, because what RAID does, right, is it makes it look like there's one disk when there's actually many. And that's very useful, especially when you're doing virtual machine stuff. So, but that's certainly a subsystem that would be a system software. Okay. So one of the things I made a note of is, because I wasn't clear about this, I didn't talk about it necessarily, is that with RAID, we can take many disks and make it look like one. But we can do the opposite too. We can take one disk and make it look like many, or more than one. And we do this by partitioning. So what it does is it sets up the disk controller, or the operating system, sets up virtual spaces. So it looks like a certain section of a disk is one disk, and another section is a different disk. So I can set up a C, a D, an E drive all on the same physical disk, or on the same RAID disks, if I had a RAID system on my personal computer. And I've known people who've gotten RAID systems for their personal computers. I haven't chosen to do that. They are a little expensive. Let's do another one here. Doing a lot of talking, which is probably good. Advantages oops, I need to get bring this up. Okay, so advantages of having many, or having one large partition versus many small ones. I'm going to go ahead and number these just for as a change. So this is the reason why you would want to put, even if you had 20 disks, why you would want to put it into a RAID, even if you weren't going to do any redundancy. So what could we do for that? Well, we could do 0, right? I mean, but 0 requires an extra disk. Does it require an extra? No, it doesn't require an extra disk. Wait. Why am I losing this stuff? Here we go. No redundancy at all. I'm sorry. That's just disk stripping. So, why I would want to use even RAID 0 versus just having many different disks. So, well, one of the things that I guess that wouldn't even be important is every single disk, as it gets close to being full, you can't put anything on there. You can't use that last little scrap of space. Well, by creating a RAID, you don't have to worry about that. That's additional to what this is. But that's special in the fact if you're doing the RAID versus having them all independent. Managing a large partition is easier. Consumes less energy. Now in this case, we might not see as much if we're doing RAID, but we might. So the next one is interesting because we had less energy, less heat, thus less cooling. So we consume less energy on the front end, which means we generate less heat, which means we need less cooling, which also takes energy. So trying to be energy efficient, right? That's a big deal nowadays. If for no other reason than energy costs money, and saving money is a good thing. So even if it wasn't for any other reason. That still makes economic sense. And the more money you can save for a company, the more money they can afford to pay you. And that's always good. We can provide more data protection. Part of that is because with one large partition, we actually have more physical memory that we can use, and so we can have some extra data protection things in place. It's also because it's faster. That's part of all of that. Easier to back up and to recover. Because it's one large partition, I don't have to do each one individually. Less physical space is actually needed. Although, that's a little interesting. Yeah. And this one's interesting because I say can be less. Software licensing can be less. It depends on how you're doing things. And so in some ways this actually applies to, say, if I have a bunch of VMs. If I want to get a license for Microsoft Office for my business, and I'm going to put it on my server, does that cover all of the virtual machines that are generated from that server? I bet you it does. So that's just an example of that. And then the last one that I have is easier to upgrade software. Because you only have to do it on one partition instead of many. All right, now let me talk about the next thing. What happened? Well, programming tools, and this is when I talk about programming tools here, Yeah, that won't work. Okay. Well. Okay, then. So what I want to talk about is different tools that we can use for creating software, creating programs. And we're going to go over a few of them. First thing I kind of want to do maybe is talk about an IDE. Well, we'll get to there. We'll get there. Okay. So, assemblers and assembly. Well, let's actually indent here. And so these are, so this creates assembly code, which is great, right? There's advantages to doing assembly code because we have full control of what the processor is going to do. And we can see things on a much lower level. There's some major disadvantages for that, though. One of the disadvantages of that is that we have to take care of all the hard stuff, right? Load this in from memory, put it here, do this, add this, do this. We can't do anything really complicated. And so that's the frustration. In fact, actually, if I said something like y equals 3x, or no, equals some character x3, times 3, right? So, and that's a Java code thing. So I'm going to replicate, say, the character d. Let's pick a different character, the character m. So then it would switch into MMM if I did times 3. So this takes, if that's done in Java, it takes 12 assembly code lines to complete that task. X equals the character M times 3. That's a lot. Okay, so, and that's it if I've already allocated X as a string. So that's a different story too. Okay, so the next one is link editors. So instead of talking about what those are specifically, the easier way to talk about it is dynamic link libraries, or DLL. So it's possible that you've been running along through your computer and you're looking at files and you see .dll. And this is a file that Java actually creates. It's most likely Java, but it could be something else. So dynamic link libraries are libraries that include processes for or modules for other parts. So doesn't make sense. I can give you an example. If you've ever been coding in Python and you've had to import something, whatever that is, then that's a DL. That thing is most likely saved in a DLL, a dynamic link library. So when you're going along and it says to reference something, what'll happen is those links won't be created until runtime. In fact, when you're loading something, when you're loading a program, let's say Word, if you've ever noticed, sometimes it's a little bit sluggish to start the first time you run it. because if it's still running in the background, right, then we can close it and it opens up much quicker. But it might take some time to get it to load, and the reason is because it's linking those libraries to where they go in the code. So there's a couple things that allow us a couple of reasons why this is a really nice thing. Oh, actually, there's a few different reasons. I'm going to actually tab this in here. So this is then a DLL is only loaded once. And so say I have a number of different files that things are written in. In fact, actually, I'm trying to think of how many files we have for our regression. Our regression is much smaller than our production code, the regression tests. And I think if I had to count them all, we probably have somewhere's in the order of about 400 or 500 different files. I could be wrong, I could be off, but it's in the hundreds at the very least. So if the first one I'm looking at, I need to include the string library. Well, no, the string library is automatically included in Java. Let's say I had to include a list, right? I want to create a linked list, and so I need to include the linked list. So I need to import that. That's how you would do that in Java. It's done differently in Python, right? Isn't it include? I think it might be use the word include. That's a C. C, you can use either include or import. I think there's two different ways to do it. I could be wrong. It's been a while since I've done C. Or C++ for that matter. But in Java, it's always you import. But if I imported that in the first file, and then I go into another file, I've got to say a second file, that is some other class that I've created. So then I go over to that class, and that also has a linked list in it. Well, then it won't bring it in twice. It'll only bring it in once. And that's what DLLs allow us to do. All right. Oh. This is only partially true. So if for some reason a DLL file gets changed, as long as it still works the same way as it did, as it was supposed to, perfectly fine. There's not going to be any issues, right? So if a developer who created this DLL file finds a bug in it, then they can fix that bug, and the next time I run my program, that new stuff will come in, provided I upgraded it on my computer and all that kind of stuff. But that DLL can be changed and fixed in one place instead of in many places. So DLL files are really nice for that. And then users can assume DLL files are present based on system or environment. There's an O there. I forgot it. So what I mean by so system would be, say I'm on a PC, there's certain DLLs I can just know that they're going to be there. I don't have to go and download them. They're just on the system. I can use them. There are other ones when I talk about environment. Let's say I'm in Java there's certain DLLs that I know will be included when I download the JDK or the JRE, depending on which one I'm looking at. Probably the JDK. Although there are some DLLs that are included in the JRE, I believe. So, Java runtime environment, and that's what you need to run Java programs. That's got to have some DLLs in it. And then the other one is Java Development Kit, JDK, Java Development Kit. Yeah. And so that would be so that you can create Java programs. So it gives you more of the source code stuff. Okay. All right. So I talked about this a little bit on these DLLs when you load the program. So if you use DLLs, when you load the program, it takes longer to load than if you didn't. So that sucks. But it allows for that more dynamicness. So that in some ways it could, because it's only loaded once, it might actually load faster. That's a different thing too. Here's another I've talked about the good things right here, right? So, but there's a bad one. If a DLL changes, the programmer might not notice. Oh, I should do this differently. Let me explain what I mean by that. If it changes, not just in the, if it changes fundamentally what it's doing. So if I have a method that's in one of the DLLs that tells me to fetch a certain item from a list, and in the nth place, if that changes, so right now I can make the assumption that I start counting n at 0 when it comes to an array or a list. But if fundamentally it changes and says, okay, no, we're going to start counting at 1 from now on, and not start counting at 0, then that change will happen, and I won't know about it. And my program probably works just fine most of the time. So there's that. And that's just something to be at least semi-aware of. And we've encountered one of those problems. We encountered one of those problems about a year ago. There was a big bug. Maybe you didn't hear about it. It was something called log4j. Let me write that up here. log4j. And so that's a module that's used in Java programming. And it's used primarily for logging. And so what I mean by logging is it would, you can use this module to write notes either to the console window, to a log file, or just simply printing it to the screen. I guess that's what console window would be, is printing it to the screen. So those are kind of usually the two ways, is either printing it to the screen or putting it into a text file somewheres. Called a log file, meaning this is what happened when you run it. So, and we generate, on a daily basis, we generate multiple 100-line long log files or more that explain all the different errors or not errors that are happening in our system. I can't show them to you. I wish I could. I don't have the the privacy. That I mean, I've signed things that said I won't show them. So, but they are quite long and sometimes very wordy, and can take a real long time to dig through. But it allows us to look for specific errors by searching through that file. Anyways, log4j is fundamental. It's used in almost everything because it logs different information that's going on with your system as your system is going on. Well, there was a bug found in log4j about a year ago. So we had to fix it. Simple problem. It's a DLL. New DLL comes out that fixes the bug. Done. Right? Wrong. Because log4j is used in so many other places, I have the new log4j that I'm using for my system. But I also am using some things created by other people. Whatever it is, right? Some kind of an assertion program or some kind of a... whatever it is, doesn't matter. And we have over 100 dependencies in our system just for regression. Each one of those, if it makes use of log4j, it makes use of the old log4j, not the new one. So I need an updated version of that program so that it uses the new version of log4j. And so it took us about 6 months to get our system up so that it purged all of the old log4j bug stuff that was a potential bug in our system. Now the good news is for our regression, it's completely behind a firewall. There's almost no chance that anyone ever would be able to get to it and use it. So was it a big deal? No, but it was something we wanted to have done so that we could get everything upgraded properly. So that's just an example of these cascading problems, right, where you might not notice. And we didn't, at least at first. Okay. All right, so let's go back here. And I'm going to go back twice because... So a compiler, this converts HLL, or high-level language. I'm gonna grab this and just pull it way down here a little bit. A compiler will, so when you compile your code, it takes it from the high-level language that it is, and so that would be Python, Java, C, C++, C#, Basic, COBOL, Fortran. Think of just keep thinking of languages. And what it's going to do is it's going to convert that into assembly code so that it can be run at runtime. Now that could leave open DLLs, and probably does, but it wouldn't have to. It depends on the language and how it's all done. So that's just how that works. Okay, so then the next one would be in... So interpreters are different. Interpreters, well, first off, they're slower. Let me give you what an interpreter does. Interpreter does not compile the code. So what happens is it comes along, and here's the interesting part. Java and Python were both designed to be interpreted languages. Now, they can be compiled, though. So most interpreted languages can be compiled. So what happens is, in an interpreted language, it comes along to a piece of code. When it sees that line of code, it converts it then, at that time, into assembly. Or, sorry, it converts the whole thing into assembly as it goes. So as it's running. Converts to... Actually, I shouldn't say assembly. It's really doing machine code at the time of execution. So when the program runs. Okay. So let me talk a little bit about IDEs. Because usually the interpreter will be embedded into the IDE. So IDE is an interactive development environment. One of the things, and I'm reading through this, there's something called source level debugging. And let me put that here. Source level debugging. So source level debugging is done in interpreters, or can be done in interpreters, because you can run the piece of code very, very easily, because you don't need to compile it. You don't need a separate step to compile it. You can just push go and it runs. So what that does is it allows us to debug our code quicker. And I think I've talked about this in the past, maybe. When I first learned how to code, I learned in C++. And I didn't have an IDE in the same way that you guys do. I don't know what IDE you guys would use. There's one called Idle, which is really stripped down, that's used for Python. I'm sure you guys used better ones than that. I'm assuming that everyone did Python, but if you didn't use Python, you might have used Eclipse, or you might have used... what are some of the other ones? That's the main one I use, Eclipse or IntelliJ. But mostly I use Eclipse. So we open up the code in these IDEs, and they help smooth out the problems so that I don't have to worry about compiling or any of that kind of stuff. It's all taken care of by the IDE. I don't know, explain. I don't know. In the past, what I had to do is I use a text editor. I would save the file in the text editor. I would go out to, I was working in Linux at the time, but I'd go out to a command prompt. I would compile the code in the command prompt, which would also include the linking. And then I could run the program, but I had to run it from the command prompt. I couldn't run it from inside the IDE. Well, there really wasn't an IDE. It was just a text editor. I think I used gvim. I believe that's what I used. It was either VI or gvim. I don't remember which one. Maybe I switched between the two. So, you guys have it easier in some ways to be able to run that. So, make use of it. I think most of you probably are already doing that. See how things work line by line, one line at a time. All right. The book spends about 4 or 5 pages talking about how Java works, Java Virtual Machine, or JVM. I'm not really going to talk about it. It's an interesting read, or go out and look up what the different Java virtual machine kind of works, because it will run Java code on it. And you need something like that in order to run any compiled version of Java. So it's probably behind the scenes. You're never going to see it, never going to know it's there. So this is what the JRE, when we talk about Java runtime environment, that's going to bring in your Java virtual machine as well, so that you can run Java code that's been compiled. Or it could just be I'm not sure. It might work on the interpreter. I don't think it works on interpreter. I think it has to be compiled. So, I think that's everything for software systems. There's a lot of definitions and a lot of stuff, so please review all those things. Try to make sure you're up on it. Then we will go on next time, and I will start on Chapter 9. What is Chapter 9? Alternate architectures. So you can tell we're getting close to the end here as far as the number of topics in the book. So, yeah, alternate systems. Alternate architectures, I'm sorry. So, and we'll talk about those, and then, and that should be about 5 times, or 3 times, about three lectures, and then about 2 lectures for Chapter 10 and 3 lectures for Chapter 11. So we only have, after today, we probably only have 8 maybe lectures left, other than Marie. So, maybe I'll start talking about doing the Marie, and Wednesday can be our Marie day. Maybe, I don't know. We'll see. I'll think about it a little bit and try to figure out what I want to do. Okay, that's all I have for today. I know it's a little bit short, but hey, now you get some time to go look at the exam and see if you have any questions for next time. Send the questions early. Send them often. That's okay. Not a problem. There's no such thing as a bad question. In fact, I had a question this last week that got me rethinking my late work policy. I won't change it for this class, but I might change it for my future classes. So, and you're welcome to challenge any of those policies. That's all good. That's all good. Very, very unlikely that I'll change anything in this class, but I might change things in other classes moving forward. Okay, I will talk to you guys in a couple days. All right, bye-bye.